All right, so good day. We are now into proving theorems in geometry. So our session objectives are as follows. So number one, name the different properties of equality and congruence. And number two, apply the different properties in proving problems in geometry. So we're going to talk about the different properties of equality and congruence and try to use all of these in proving statements in geometry. Now, when we prove statements in geometry, we are going to use lots of theorems, definitions, postulates in giving reasons for every statement that we are going to prove. Okay, but let us first start with our discussion of the properties of equality. So what are the different properties of equality? We start with the addition property of equality. So here we say for all real numbers a, b, and c, and d, if a is equal to b and c is equal to d, then a plus c is equal to b plus d. So simply, in the addition property of equality, we are just adding all of the numbers given in a particular equation. Okay, next. So, the subtraction property of equality. So, in this case, if a is equal to b and c is equal to d, then a minus c is equal to b minus d. So, in the subtraction property of equality, we are just going to subtract also all of the numbers. As simple as that. Next, we also have the multiplication property of equality. So, in the multiplication property of equality, it's very basic that we are just going to multiply all of the numbers. So, here we have if A is equal to B, then AC is equal to BC. So, we are provided with an additional letter which represents a constant. So, if we multiply that to A and we multiply also that to B, so the answer will just be the same because we know for a fact that A is equal to B. So again, in the multiplication property of equality, we are just going to multiply the numbers. Now, the next one is the division property of equality. So in the division property of equality, we are just going also to subtract. To divide, I mean, sorry. So if A is equal to B, then A over C is equal to B over C. So in this case, the fraction bar there represents the division symbol. So that will be A over C is just equal to B over C. So simply, we are just dividing. Next, we also have our substitution property of equality. Okay, substitution property of equality. Now, in the substitution property of equality, what we do here is we are just going to substitute, okay, all of the given values. So, if the measure of angle A is equal to 60 and measure of angle B is equal to 60, then the measure of angle A is equal to the measure of angle B because we're just going to substitute the value. So, the measure of angle A is actually 60 degrees. So, that will just be equal to 60 degrees. So, in some cases, in the use of the substitution property of equality, we're going to substitute the values. Okay, so say for example, if we're given if x plus 3 is equal to 5, okay, and x is equal to 2, so using the substitution property, we just say 2 plus 3 is equal to 5. So this is the use of the substitution property. Now later, when we have the examples, you are going to see that actually the numbers are being substituted. So when you see that the numbers are being substituted, instantly you will think about that is the substitution property of equality. Okay, next. So we also have the distributive property of equality. So you know already the distributive property, right? So if we have A times the quantity of B plus C, so that will be equal to AB plus AC. So, very basic. We are just going to distribute. So, when we distribute, we are actually multiplying. So that is the distributive property of equality. Now, we also have the different properties of congruence. Now, what are the different properties of congruence? Okay, so congruence is symbolized by this. So that is the congruent symbol. Okay, now for equality, of course, we know that it is just the equal sign. So that is equality. Okay, now, what are the different properties of congruence? So, the first one is reflexive property of congruence. Okay, so, in the reflexive property of congruence, it states that, now, if we have a line segment AB, this is actually congruent to line segment AB. So, when we say reflexive property, whatever is it that you have, okay, here is just the same as what we have also here. So, line segment AB is congruent to line segment AB. So, it is just a reflection of its own. Okay, now, say for example, this one. Now, if we have this triangle ADC. So, we have triangle ADC. How are we going to show the reflexive property of congruence? If we're going to separate the two triangles, so we have triangle 1 and this is triangle 2. So if we're going to draw them, okay, so this will be triangle ADE. Okay, and we also have the second, so this is triangle DEC. Okay, so that's triangle DEC. Now, can you see both sides or sides that are the same or that are congruent? So we can say that line segment DE is actually congruent to line segment DE by reflexive property. Okay, so that is reflexive property of congruence. Okay, now, in this case, if we're going to go back to this figure, okay, join the triangles. Okay, so we have DE here as the common side. Okay, so if you're going to split the two triangles, we say that we have these two that are just the same sides. So this illustrates the reflexive property of congruence. Now, we also have what we call as the symmetric property of congruence. In the symmetric property of congruence, we say that if angle A is congruent to angle B, then angle B is congruent to angle A. Now, what can you say about the letters or the angles? So, we say that the angles here are just being interchanged in their position. So, here we have the first angle A and then the second is angle B. But here we have angle B and we have angle A. So, interchanging their positions does not affect their congruence. Okay. So, we say that angle B is still congruent to angle A. Alright, so let's look at this. So, whatever you do in the figure for so long that they are equal. So, we say here that if this triangle ACB, and we have triangle still, this is ACB, because it's just being rotated. So, but if we're going to consider this side, okay, and also this side, we say that side AB or line segment AB is just actually congruent to line segment BA. So, interchanging the letters does not affect their congruence. So, they are still equal by the symmetric property of congruence. Okay, so next. So, we have the next one, the transitive property of congruence. Now, in the transitive property of congruence, we're just going to relate all of the given letters or given signs or given angles. Okay, so we have here, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. So, we're just going to relate angle A, angle B, and angle C. So, since angle A is actually equal to angle B, Okay, and we say that angle B is also equal to angle C, so it follows that angle A will be equal to angle C. So in this case, they are all equal or they are congruent. So this is the transitive property of congruence. Now, say for example, if A is congruent to B and B is congruent to C, so therefore, what can we say? A is congruent to C, illustrating the transitive property. Okay, so those are the three properties of congruence. So the first one that we discussed is the properties of equality, and this one is the properties of congruence. Now, it depends upon the given symbol. If the given symbol is in terms of equality, then that is the property of equality. But if the given symbol is congruence, that will be property of congruence. Now, how do we illustrate that? So say for example, if I have AB is equal to AB. Okay, line segment AB is equal to AB. Therefore, this is reflexive property of equality because the symbol that we used here is equality. All right. But if we say for example, CD is congruent to DC. So we use the congruent symbol. So this will become, what property is this? So this is the symmetric property of, since we use the congruence, so we're going to use the congruence symbol. Okay, now take note or be careful about the use of the symbols. Okay, next. So these are just some of the summary of our properties of equality and the properties of congruence. So all of the presented properties are summarized in here. All right? So let's see. Next. So in this given examples, we're going to justify by giving the property of equality or the property of congruence that is used. Okay, so we have the first one. So let's see. If Tx is equal to Bk, then Bk is equal to Tx. Now, be careful about the sign. Alright? So, what do you think is the property of equality or property of congruence? Okay? That is being illustrated in this. Okay? So, Tx is equal to Bk, then Bk is equal to Tx. Alright? Very good. So the property that is illustrated here is actually our symmetry. Okay? Symmetric property of, because that is equality, so equality symbol. Symmetric property of equality. Okay, next. So let's see. 8 times the quantity of m plus n is equal to 8m plus 8n. Okay. So what is the illustrated property here? All right, very good. So because we can see that we are distributing, so therefore this is the distributive property of, because it's equal sign, so distributive property of equality. Okay, next. So if CT is equal to 12 and PR plus CT equals 20, then PR plus 12 is equal to 20. Okay, now, take a look at this. You have CT which is equal to 12, and you have the equation PR plus CT equals 20. And look at that. So, we have 12 here. Therefore, what property is being illustrated in this example? Okay, very good. So this is actually the substitution property. Yeah, so this is the substitution property of, because that is an equal sign, so we're going to use the equality symbol. Substitution property of equality. Okay, next. So we have measure of angle HIT is equal to measure of angle HIT. Okay, so they are just the same. Okay, what property is illustrated in this example? So, as you can see, they are just the same. All right? the same angle. So therefore, very good. This is, yeah, so this is the reflexive property of because equal sign equality. Okay, so reflexive property of equality. Now, let's proceed to the next. So, if angle S is congruent to angle P and angle B is congruent to angle S, then angle P is congruent to angle B. Alright, so what property is this? Okay, very good. So the property here is transitive. Okay, transitive property of, because you use the congruent symbol, so that is transitive property of congruence. Okay, very good. So we now apply the different properties of equality and congruence in identifying different situations. Okay, so next. So the next part is introduction to proving. So what is again a proof? So a proof is a logical argument in which each statement you make is supported or justified by given information, definitions, axioms, postulates, theorems, and previously learned proven statements. So this is a proof. And we're going to use this, all of the definitions, axioms, postulates, theorems, in giving reasons to given problems later. Now, when writing a proof, it is important to justify. So we are going to justify each logical step. Okay, meaning to say we will be having justifications. You can use symbols and abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. Okay, now, this begins with a hypothesis, and we have the use of the definitions, postulates, properties, or theorems, and we are going to arrive at a conclusion. So, in the conclusion part, this is actually the statement that we are going to prove. Okay, later you will see that proving statement. Okay, now remember, a postulate is a statement that is accepted without a proof. Okay, meaning to say it's already a general statement that is already accepted even if you don't prove it further. So what are just some examples of postulates? So we have SSS, congruence postulate. These are actually, guys, the triangle congruence postulates. These are used to prove triangle congruence. But we're going to talk about this more during triangle congruence. Okay? Next, we have the SAS congruence postulate and then the ASA or the ASA congruence postulate. So if you can see, we have sides, two triangles, okay, with three sides. Okay, so we can say that they are actually congruent. So in the side angle side, we have side, angle, and side. So the two triangles are congruent. In the angle side angle or the ASA, you have the angle, then you have the side in between the two angles, making it ASA. Okay? So, and also, we have the angle side. So we have this angle, and then the side. That is not between the two angles. Alright, so we're just going to discuss more of this as we proceed with our discussions. Okay, now, also, a theorem is a statement that is accepted after it is proven deductively. So, theorems are not accepted instantly, but they need to be proven further. Okay, so say for example, the isosceles triangle theorem. So if we have triangle FIX or triangle fixed, how are we going to illustrate this using the isosceles triangle theorem if they are actually isosceles? So if two sides of a triangle are congruent, then the angles opposite them are congruent. So if we say that, so if side FI is congruent to side IX, okay, then we say that, so it's stated in the theorem that the angles opposite them. So here, this is the angle opposite, so therefore, angle X is congruent to their opposite angle F. So we just proved the isosceles triangle theorem here. Okay, next. A conjecture is an opinion or idea formed without proof or the sufficient evidence. So we already used conjecture or a statement that is formed, okay, so that we can have an evidence or an explanation, a counter example. So that is actually a conjecture. Now, proofs can be written in different ways. So number one, we have the paragraph or the informal proof. So in the paragraph or informal proof, this is a type of proof where you write a paragraph. So just write a paragraph to explain why a conjecture for a given situation is true. So let's see. We always start with a given, and this is the proving statement, the one that we're going to prove. Now, let's look at this. If angle LOE and angle EOV are complementary, then prove that side LO or line segment LO is perpendicular to side OV. Okay, now you're just going to write the proof, the explanation using a paragraph. So if we're going to write the paragraph here, we can just actually say that since angle LOE and angle EOV, okay, are complementary. Okay, are complementary. So we say that therefore, angle LOE plus angle EOV is equal to 90 degrees. Okay, so therefore, thus, line segment LO is perpendicular to line segment OV. Okay, so because we know that when we have perpendicular lines, they actually form right angles, okay, which are actually equal to 90 degrees. So this is the first one, paragraph form. Okay, so the second one is the most commonly used, two-column proof or the two-column form. So again, we have statements that need to be proven here. So given measure of angle SEP, okay, SEP is equal to measure of angle TER. So this one. Okay. Now, in the statement, you need to prove that the measure of angle 1, this angle, is equal to measure of angle 3. Okay. So, in doing the two-column proof, we always do the table or draw the table. So, in the first column, we have the statement. And the second column, we have the reason. And we're going to write the different statements and give the support here. Okay. So, in this case, we have number 1. So, measure of angle SEP is equal to measure of angle TER. So, the reason is actually given. Okay, because it's already given here. Okay, that is actually the first, always the first part of the proof, the two-column proof. Okay, so you have the given. And then, you're just going to supply the next statement. So, statement number 3 here, statement number 5. Okay, so here, we have measure of angle 2 plus measure of angle 3. You're just going to give the statements here. Okay? So, this is again still the angle addition postulate, right? Okay, and then here, measure of angle 2 is equal to measure of angle 2. You have reflexive property of equality. Okay? So, you're just going to supply the reason here. Okay, another is the flow chart. So, in the flow chart, you can see that there is a flow of the statement from this first, going to this, and going to this. So, just the flow chart. But the most common that we use is actually the two-column proof. And we're going to deal more about this in our succeeding discussions. Alright? So, again, we also have the indirect proof. An indirect proof usually is paragraph form. The opposite of the statement to be proven is assumed true. So, opposite. Until the assumption leads to contradiction. Okay? So, this is the indirect proof. So, we have here, given triangle BEL is a isosceles triangle with vertex angle B. So, this is the vertex. Prove that angle B is congruent to angle L. assume that angle B is congruent to angle L. So this is the assumption. We need to assume. So here it states, given the triangle BEL is isosceles, okay, therefore, BE is congruent to BL by the definition, and angle B and angle L are congruent, because if two sides of a triangle are congruent, then the angles opposite these sides are actually congruent. Thus, the assumption is false, and therefore, angle B is congruent to angle L. So this is just an indirect proof. All right. Now, we say that we always use the two-column proof, right? Now, let's just have this example. So, write a justification for each step. Given that angle A, okay, this angle, and angle B are supplementary, and measure of angle A is 45 degrees. So, this is the illustration. Now, you are provided with a statement and then the reason as the two-column proof. So, again, the very first statement, okay, is always the given. So, measure of angle A and angle B are supplementary, measure of angle A is 45. So, this is also the first reason, because it's already given. Now, number 2. So, we need to prove measure of angle A plus measure of angle B is equal to 180. So, because we are adding, therefore, the reason is definition of supplementary angles. Okay, because you are adding them. So, that is the supplementary angles. Next, 45 degrees plus measure of angle B equals 180. So, we know that measure of angle A is 45 degrees. We substituted there 45 degrees. So, therefore, our reason here is the substitution property of equality. Next, so we are now going to prove measure of angle B is equal to 135 degrees. So, our reason here is subtraction property of equality. Why? Because we have already 45, so 180 degrees minus 45 degrees will be equal to 135 degrees. So, what we actually did is to subtract. So, this is actually the subtraction property of equality. So, this is how we illustrate the two-column proof. Okay, again, let's have this. So, use the two-column proof to prove the statement below. So, we have given B is the midpoint. So, you have B there. Okay. Now, of AC, then AB is congruent to EF. So, AB is congruent to EF. Now, let's see. Number 1 statement, B is the midpoint of AC. So, number 1, we have given. Okay. Again, that is the very first statement. Next, number 2. So, we say that AB is congruent to BC. Okay, how do you know that AB is congruent to BC? Because we have the midpoint. So we say that B is the midpoint. Okay, making them equal, right? So B is the midpoint of AC. Okay, next, number 3. So we have AB is congruent to EF. Okay, so AB is congruent to EF because, so AB, if we say that AB is congruent to BF, then AB is congruent to EF. Okay? Now, but because AB is congruent to EF, here it is already given, right? So, our statement or the reason is given. And the number 4, BC is congruent to EF. So, this is illustrated by the transitive property of congruence. Okay, because we have the congruent symbol. All right. Next, number 3. So, we also have this one. Okay, so the given is just the line segment XY. Prove that XY is congruent to XY. So, we are given already with the reason. So, number 1, still that is given. Number 2, XY is equal to XY. So, that is reflexive property of equality. Okay, now how do we prove? XY is congruent to XY. Definition of congruent segments. Okay, and then next, number 4. So in this case, we're just going to complete the proof. So given angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. So prove that angle 1 is congruent to angle 3. So first, letter A. So we are provided already with the statement. So there. So given. So always the given. Next, angle 1 plus angle 2, 180. Angle 2 plus angle 3, 180. So definition of supplementary angle. So that is the reason. Okay, next. So for letter B, substitution property. So we are just going to write it here. Okay? So measure of angle 1 plus measure of angle 2 is just actually equal to measure of angle 2 plus measure of angle 3. Okay, substitution. And then, number 4, measure of angle 2 is equal to measure of angle 2, reflexive property of equality. And then, measure of angle 1 is equal to measure of angle 3. So that is the subtraction property of equality. Okay? And then lastly, we have letter D. Here's the statement. Angle 1 is congruent to angle 3. Definition of congruent angles. Alright? So that is all about the different proofs.